So I'm going to try to do this ADF 4360 chip here, and what I'm going to do is I'm going to just put a small connection on this pin here, which is the mux out pin, which is programmed in the latest firmware to give out the lock no lock, and it'll go high when it's locked and low when it's unlocked. So that's what we're going to try and do now. And I've got some little bit of wire wrap wire here. So here it is, and this is my little tool that I use for this. Sorry, it's not in focus, but I'm just going to strip it. Just going to let us break out the connection so we can easily rest a scope probe on there. So I'm just going to look at that. It's a bit long, so I'm just going to trim it down a little bit. There we go. Probably good enough. What we're trying to do. Hopefully you can see that. Okay, so first things first. Probably put a little bit of flux on there. So let's find my flux gun. I'm doing this a little bit the wrong way up here. Oh, way too much, never mind, it'll do. I'm also going to tin that pin. Now the chances of me actually getting that pin without touching the other ones is quite remote, but we'll see what we can do. I'm also doing this upside down so I get the camera in, so apologies for that. There we go. So I've tinned it. The nice thing about this wire wrapping wire is that it does tin really well. I can't know if it's actually, this stuff is silver plated. Sorry about my hand getting in the way here. So I'm doing this backwards. See if we can get it right on the pin there. I'm just trying to get it so it really does connect well. I hope they haven't had too much coffee. Okay, and the other thing, this is something that I learnt, seems like common sense now, but something that I never bothered doing, but what I learnt once when I was working over at European Space Agency, all they do on this space rated stuff is they put a little loop on the cable as a kind of strain relief. And that's what I'm going to do here. There's going to be a little bit of pull on there. The reason they do it in the European Space Agency like that is for vibration. And they used to have an absolute length that they had, which is, I don't know, it was something like a centimetre or something. It wasn't for just breakouts. This was for putting stuff on spacecraft, for connecting pads on boards up to connectors and whatnot. And they used to solder to the pads, and then they'd have a little loop of about a centimetre or so, and then they'd put some glue down on the board. Of course, this was all Teflon wire, none of this plastic stuff which I'm using here. Now I'm going to do it a little bit differently because I don't have this really expensive glue, but I do have a hot glue gun. There we go. And we'll leave that for a moment, and that'll be our little probe point. And the other thing that we're going to look at is we're going to have a look at the actual output of the PLL, and again I'm having to look at this sort of indirectly through the camera. This is a differential output, and here it is. So we'll look at that on the spectrum analyzer as well and just see exactly how it turns out. So I'm going to put it all back together again now, or well, not completely, but just reassemble it so we can have a look at the this mux out, which tells us whether or not it's locked. So here we go, I've got the scope probe connected up, and we're going to just switch the scope on and see how it goes. I've actually got this connected up to another scope so we can actually see this turning high with a bit of luck and the wind behind it. So it takes a few seconds to boot, so I'm just going to switch it on. Interestingly, it's gone high already, which I wasn't quite expecting, but there you go. Now there we go, it's gone low now. A little bit low. Coming up. Should put a mirror in front of the scope, shouldn't I? I think we can probably take what it does right at the beginning as a pinch of salt. There you go. This is when it's actually starting to work. It's absolutely high. Now, what I'm going to do is I'm just going to put it on trigged. No, there doesn't seem to be anything there. Let's just adjust the trigger level, make sure it's not oscillating. It's not, it's rock solid. There you go. So it looks like it is actually locked. Next thing we're going to do is we're going to have a look at the spec and we're going to have a look to see what the output of the this looks like. So here's the probe that I'm going to use, the RF probe that I'm going to use to probe the PLL. And if you have a look at this, it seems fairly Heath Robinson. That's probably because it is, or jury rigged to our American friends. And what this is, it comprises of a standard SMA connector at the end, 50 ohm SMA connector. This is actually an edge connected one. And hidden underneath here is a bifilar wound common mode choke to get rid of all those common mode nasties. There's a short length of underneath the Kapton tape. There's a short length of coax. This is solid outer coax, or semi-rigid. And then just at the tip here, there is a 1 picofarad capacitor hiding underneath there, and at 1 gigs 1 picofarad is about 160 ohms or something of reactance, and a little pin here which we can use to directly probe. Now you've probably seen as well other people use things like magnetic field probes and electric field probes and whatever. What I was trying to do was I was trying to probe directly the point, hopefully without loading it too much, although 160 ohms is pretty low impedance on there. But hopefully what I was trying to avoid was to see if the jitter on the output of the PLL, that was actually some sort of mixing product that was just appearing on the perhaps the power supply lines and not the actual VCO output. So I'm going to do a direct probe here. So this is the probe I'm using. It's quite a slow scan. I'm looking for 1 megahertz band, and also it's I think it's a 300 hertz receiver bandwidth as well. So it takes a little while to scan. And I'm going to have to try to keep this probe on one of the outputs for the duration, which I think is just over 10 seconds. There you go. And these are the side bands. That's the fundamental. So you can see there's still a fair bit of jitter on there. Not great, but it was locked.